All right, today's lesson's a big one. If I get through all of it, great. If I need to continue it until tomorrow, so be it. But we're going to do this today and tomorrow because it is that big of an idea. Are you ready? Okay, so it's Extrema again. And you might think, God, I've been doing Extrema all year. That's not new. And to some degree, you're right. You have been doing relative or local Extrema all year. What you haven't been doing is absolute extrema. So let's talk about the review. We've talked already about local extrema. That's where it's a max in a small neighborhood. So for example, this point there, is that a max? Yeah, but it is the max. Yeah, so now you're talking about some very important articles. A max versus the max. That's different. It's a local max because I can draw a little neighborhood where it's the big guy on campus, all right? But as far as the whole world, it's not so much the big guy on campus. It's not the greatest value. This doesn't actually have an absolute extrema. It has a local max and a local min, but not absolute. So today we're talking about absolute extrema, not just local. Consider here this graph, which has a mixture of stuff, right? Now, in this graph, you have a couple points shown, but A is special because it is both an absolute and local min. It's local min because there is a little neighborhood where it's the toughest, yeah? Or just weakest, I should say, the smallest. I think you'll agree that it's the least value in its neighborhood. But in terms of the whole world, it's also the smallest in the whole world. You with me? Now this guy is a local max because it's great in its neighborhood, but it's not the greatest. So it's a local or relative max. I'll use those interchangeably. You can use either. They're both accepted. That point I thought was something going to happen, but it turns out to be nothing. It was a critical number. There's a min at C, but it's just local. An absolute and relative max at D. And at E, that's a local min. I don't have it labeled. It's a local min because it's the smallest in its neighborhood, but not the absolute smallest. Now, that graph absolutely has an absolute min and max, but not every graph does. This guy, does it have an absolute min and max, or just one, or neither? Absolute min only. Okay, what about the second one? Absolute min only. It goes forever up, so it cannot have an absolute max. What's going on there? Is there something there? What is that? Is that a circle? Does that look like that? Let's go here. Would you put a little circle there open and then a line coming up if it's not connected here? So what about that? Absolute min? No. Okay, now that point's not included, so you can't say that's the absolute min. Then I always hear students say, what's the point right before that? Well, what does that mean? Right, that doesn't mean anything. There's no, so are you saying that's like 100th away? Well, isn't there a point a billionth away that's smaller? So there is no absolute min or max. There. That open interval kind of ruined everything. What about the fourth one? Absolute min, not max. Okay, and what about this last red one? Is there any point that's lower than all others? Is there any point that's higher than all others? So it has no absolute extrema at all. Okay. We talked about how a point can be both the relative max and the absolute max or min, depending on the case. Now let's go to a little more. All right. So the definition, what makes an absolute extrema? I kind of just said it in that last red one. When I said, is there a point higher than all others? That's the definition of an absolute max. If it is higher by y coordinate greater than all others. So you could say f at c is the absolute max of the function if that y value is greater than or equal all others. Now that's pretty wordy, and that's why we invented symbols. So the math way would be to say it this way. F at C is the absolute max of the function if F at C is greater than or equal to all points on the curve. That's a heck of a lot less writing than our symbols delay. Yeah? Are you with me? Okay, looking back at those pictures, where do absolute extrema tend to occur? There's really two things that are special. What's one place an absolute extrema can be? An endpoint, okay? This is special because I cut it off there. Endpoint is one place an absolute extrema can be. Where else? Critical numbers. Beautiful, you nailed it. Okay? Critical numbers or endpoints. Those are the only place they can be. It has to have something special going for it. Now, here's some basic ideas. Let's think about these. If a function is continuous on a closed interval, there must be an absolute max. So imagine closed interval means it has endpoints included. Endpoints included. They are not letting it go forever. They're cutting it off. So if you put a dot here and draw some kind of function, not some kind of crazy non-function, do something, whatever you want. But at some point, it's got to end, and you never can lift your pencil. Does that have to have a point higher than all others? It does. That is true. If a function's continuous on a closed interval, it must have an absolute max. And what about the second one? If there's an absolute max, it must be continuous on a closed interval. Is that the case? If I told you some function, I'm telling you there's a function that has an absolute max. Does that imply it must have been continuous and had endpoints? But give me an example of a graph that would have an absolute max but doesn't end or doesn't go continuous. I heard the sine has an absolute max. That's true. A parabola. Those don't necessarily end, and yet they have absolute maxes and mins. So that's not necessarily true. I'm just going to say false because it does say must, and that doesn't have to be the case. All right? If a function has an absolute max, it must be at an endpoint or a critical number. If I told you f has an absolute max of 3, what must be going on there? Would you know for sure it had to be an endpoint or a critical number? Yes. Yes.
For the first statement.
Yep.
If the function is like y equals 1, then
Yep.
what would the absolute max be? 1?
Good question. So y equals 1. Does it satisfy the definition? Is there a y value that is greater than or equal to all other y values?
Yes.
So yes, it does. I know it's weird, but yeah, that would be an absolute max. What else would it be? And also be an absolute max. So that's a weird case. That's good to think outside the box. Yep. Okay. Now, those ideas are really the basis, the true ones, the basis of the extreme value theorem. I will often abbreviate this EVT. Most textbooks do. Our book calls it something weird, so I'm definitely not going there. But the EVT is a theorem that proves existence, like the IVT you've already learned, and the MVT, which you haven't learned yet. But there's a lot of VTs, and there's 3 VTs, and we'll talk about that. But the extreme value theorem is just fancy parlance for if a function's continuous on a closed interval, it's got to have an absolute max in it. It must. And that if it has an absolute max or min, if you're looking for one, the only places you have to look are at endpoints or critical numbers. You don't have to do some kind of big old first derivative test. You just need to find the critical numbers, find the endpoints, and say what wins. All right? So this is kind of like gathering candidates for an election and then seeing who gets the most votes or tallying the votes. Think about it this way here. if I gave you, find the absolute extrema of this cube on the closed interval, now surely a cube without any restrictions wouldn't have absolute extrema. But because I am cutting it off, it will have absolute extrema. The question is, where are those endpoints in reference to the curve? You know, are they here? Or are they here? So many different places could result in totally different outcomes. But we definitely know that the absolute extrema must occur at endpoints or critical points. You will, on absolute extrema problems, always start by writing the theorem. It's justifying to the reader, hey, this is why I'm only looking here, okay? I'm referring to the theorem that says the only places that can be are these. Feel free to abbreviate endpoint or critical point. You can say critical point or critical number. I don't care which there is. Are you with me so far? All right. Now, just like when you do a first derivative test, you need to find what are the critical numbers. So you say, hey, the critical numbers are where the derivative is 0 or undefined, and the derivative is 3x squared minus 3. And so this would occur at plus or minus. Okay, I thought maybe we could just look at that, but I guess we can't. So let's factor out a 3. And then what makes that 0? Okie dokie. Thank you. All right. Now here's where it starts to be different, and for the first week or so, people will get two ideas confused. Now, the problems we've been doing, then we say, okay, now you do a sign test, and you say the derivative is going negative to positive, and that's a mean, cha-cha-cha, right? That's relative extreme. That's not absolute extreme. You don't do that here. Instead, you say, all right, now I just need to figure out who has the greatest and least x's and y's. So the candidates are the endpoints, -2 and 0, and the critical numbers, 1 and -1. Those are the only places the absolute max and min can occur, the only ones. So if you put -2 in, now where do I put -2? Into the derivative of the function? The function. You're trying to find the greatest values of the function. So put them into f, not f prime. That's also a pretty common mistake. If you put them into f, then you get -2 cubed minus 3 times -2 minus 1. You got there -8 plus 6 minus 1, which is -3. Okay. F at 0, what do you get there? -1. F at 1, 1 minus 3 minus 1 is -3. And f at -1 is -1 plus 3 minus 1, which is 1. I agree. All right. Now, all we have to do is say, all right, what wins? The absolute max value of f is, what is the max value of the function? What's the greatest of those possibilities? 1. The absolute max value of the function is 1. And this is gravy or frosting, but not necessary. The justification, if you were to say that, it's because 1 is greater than the other candidates, because it's the greatest. And actually, you could say that in symbols, because 1 is greater than the other candidates. Sometimes you will see that in words. Some textbooks will say, because 1 is the greatest of the candidates, and they will say it actually just like that, okay? Or because 1 is the greatest of the candidates. You follow? Okay. The absolute min value of f is -3, because -3 is the least of the candidates, or in symbols, whichever you like. Do you understand? Try one on your own, or with your math and English. You're already getting lazy on me and thinking you can really write that. Yeah, you really have to write that. Every. You sure you use the chain rule? Do your derivative well? I believe you should get one critical number. Yes. Hopefully it's in the interval. If sometimes happens the critical number is not in the interval, that's a likely problem that happens. Did you get a critical number of 1? Okay, good. Keep going. Ready? Or it looks like people are still writing. We'll give you another minute. Yeah, that makes sense. Be patient. All right, ready? So what is the absolute, let's do max first. What's the absolute maximum value of the function? 1. My g of 2, no está correcto. It's g to the 0. I got you. I was hoping for something more fun. Now I agree with your 1. The absolute max is? Absolute max value of g is 1, and that's because 1 is greater than e to the negative 1. The absolute min value is e to the negative 1, or 1 over e, yeah? Because e to the negative 1 is less than. All right, you with me so far? Yes.
Do you care if we say like absolute max is at like g of 2, or if we say there is 1? Like, is there?
The question usually reads, so that's a good question. We'll get more into this tomorrow, but the question will sometimes be asked 2 different ways. Sometimes the question will say, where does the absolute min occur? In which case, that's really a reference to x. You'd say the absolute min occurs at x equal to 4, x equal 1. Usually on the free response, the question instead asks this: what is the maximum value of the function? In that case, then you should report the actual value, not where it is, but what it is.
Okay.
Okay, and we'll talk more about that tomorrow. That's a good question. All right, the harder ones, and this is more of a college. This happens a lot in college exams, but not a lot on the AP exam. I can't remember one case in 15 years where they've asked this question, but still, it's good calculus. Find absolute extrema on an open interval. Now, because it's an open interval, absolute extrema aren't guaranteed to happen. They could happen, but they don't have to happen because it's not satisfying that condition of if it has continuity on a closed interval, it's got to have it. Well, these are on an open interval, so it doesn't have to have it. Could have. You with me? Okay. Now then, this will look a little more like your first derivative here test, but let's start with, it does say absolute extrema, so I'm still going to state the EVT. Absolute extrema must occur at endpoints or critical points. Now the endpoints really aren't there. Negative infinity to infinity, I guess you could say. It's not really endpoints at all. So I guess we're just going to focus on critical points. if the derivative is 0 or undefined at 2/3 x to the negative 1/3, does that have critical points? Is there a critical point? Yeah, x equals 0 is a critical point. Okay. Now, you really have to establish, all right, what's going on forever? There's no endpoint, so it's forever before and forever after. If the function is increasing forever before and then forever after, well, then nothing's going on. If the function is increasing forever before, then decreasing forever after, then it must have been a max. And if it's decreasing forever before and increasing forever after, it must have been a min. But the idea is forever. All right. Now, that said, this will be more like a extrema kind of, maybe we should do the endpoints, which are negative infinity, infinity. No, let's just do, this is the way, at least the Rogowski book does it, which is mine, so let's go with it. What about h prime? Before that, we're looking at what? Positive or negative? Negative. Is it okay to put a negative in a root? If it's a cube root, yes. Yeah. Is there such thing as a cube root of a negative? Yeah, okay. So it's negative before and positive after. What about at 0? Undefined. What do you reckon the graph looks like? So it's continuous. It is continuous. So it's decreasing before, and the derivative doesn't exist at 0. What's probably there then? It's a Siegel function. It looks like that. Okay. Now, that said, you don't have to have a picture. You just need to be able to conclude. You would say something like, now here's where the first derivative test is not going to be used. We're using a conclusion that's made to talk about why does that have to be the absolute, what, min or max? Min, okay. What is the absolute min value? What at 0, what do we get? 0, yeah? Do you agree that when you put in 0, you get 0? Yeah. The absolute min of h is 0 because this will be like the first derivative test, but a little more powerful language. Because h prime is negative for all x before 0, and h prime is positive for all x after 0. And that all x is a little more powerful language than we normally do for a relative extrema. I wouldn't need for all x for a local or relative extrema. It's for the absolute that you would need to be that powerful. Does it have absolute max? No, it grows forever after 0, so it cannot reach, probably does not reach an absolute max. You with me? Okay. You try, please. Try that one on your own. It's a little easier than the one we did just now. Use the graph knowledge as a backup to guide you, but it's not justification. I know you know what the graph looks like, but or have an idea. Use your calculus as justification. Ready? Is it 3/2? All right then. Too fast. Okay. And yes, you are crazy. Please. Okay. So, does the derivative, am I right in thinking the derivative goes positive to negative? Tell me why a pre-calculus student would say that makes sense. Actually, they wouldn't know derivatives, so never mind. But why do you know it makes sense? Yeah, it's a downward opening problem. It should be doing it, yeah? Okay, so what do we have? A max or a min at 3/2? All right, now that's not my justification. I'm just kind of playing around. So f at 3/2, what is f at 3/2? 17 fourths? Anybody? Can I get it? Yes? Okay. The absolute max value, here's my conclusion. The absolute max value of f is 17 fourths because, why? F prime is positive for all x before 3/2. F prime is negative for all x after 3/2. You follow me? Okay. I'm going to finish the rest of these notes tomorrow. Tomorrow we'll do kind of in-class AP practice kind of stuff. This homework is due the Monday after. Seniors, you got to turn paper to the This is due Monday after break. Okay? You're welcome. You're welcome. Okay, so now I want to finish. We'll probably go over question on 60. I don't know if we'll get to questions on 62, but I want to first finish going over extra practice 61, which is I think it's colored and it's got a staple, some are blue, some are pink, some are nice. I might got some white ones in there. Okay, so I'll finish going over the notes tomorrow. We'll do AP practice. That's not it. It's here. Okay, where do we leave off, people? Page 3, number 8. This guy? This one? Not this one? B?
Approximate the value of y equals the square root of 1 minus sine of x.
Oh, I think I have my slides in the wrong one. Y equals the square root of x. Those tangent line problems?
Yes.
Like this?
Yes.
Okay, here we go. All right. So this guy is, so what was the point you used? To write a tangent line, you need a point, a slope, and a point slope. What is the point you used? 0, and y at 0 is 1. Okay. How do you find the slope of a, take the derivative? Was your derivative something like 1 over 2 root 1 minus sine times derivative of the inside, so negative cosine? Yes? Yes?
Yes.
Okay, where do you evaluate that at? At your point of tangency, so at 0, 1. So what did you get for a slope? Negative 1/2, okay? So your tangent line should be something like y minus 1 equals negative 1/2 of x minus 0. All right, now that's a great, I'm not sure, I want you to understand the point of this. So I have no idea what this curve looks like, but let's say the curve looks like this. You with me? We just found a tangent line at 1. And I think you'll agree that at a point really close by, 1.01, the y of the curve and the y of the tangent line are pretty doggone close. You with me?
Yeah.
But it's a heck of a lot easier to put 0.01, negative 0.01. Oh, sorry, the point of tangency is 0. Sorry, negative 0.01, which would be on the left. Whatever, you get the idea. At any rate, my point is this. A tangent line is really doggone close to the curve in the neighborhood you look. And it's a heck of a lot easier to put a point into a line equation than it is to a mesh equation. So you think, well, I'm just going to put negative 0.1 into my tangent line. That's a good estimate. So where's that negative 0.1 go? Well, surely for x. So y is 1 minus a half of negative 0.1 or negative 1/10. That's 1 plus 1/20th. And therefore your answer is 1.05. Okay? For 3, did you get something like, surely it should be close to 8. 8 and 3/16. Okay? How did that one go? Okay, we'll come back to stuff in a second. Let's get through at least the answers so you know if you did this well. I'm not sure what I was thinking here. I was thinking I was getting really cute, making that a great problem, but that's a pretty stupid problem. And actually, a pre-calculus student could do this. If it has a max, what kind of quadratic is it? That guy. So let's just do this in a pre-calculus way, shall we? Y is, because it's a max, isn't the max at the vertex. So let's just do normal vertex form. What would this be vertex form-wise? X plus 1 squared plus 3. Now, what would have to be here if I'm going to get that kind of product? Some kind of negative. So I just put an A there, and I said A has to be negative. And really, there are infinite possibilities. There are infinite number of quadratics with a max there. So that was a kind of a dumb question. My bad. All right, how about this guy? If the function changes at a rate of 2 more than the x coordinate, what do you make out of that? F prime is 2x or x plus 2? X plus 2. So f is x squared plus 2x plus c. If you integrate, how do you get the c? You plug in the 0.71 and you get your answer x squared plus 2x minus 62. Wait. Okay. This guy, function changes the account, let's set the x and y, find the function. Did you get something like the function is a line with y equals negative 2x plus 4? That one I kind of did a little bit of calculus, then I did just a little bit of trial and error. We can come back to that. How are these areas with calculator going? 87.333? Just because you can use your calculator doesn't mean you don't show any work. You show me the integrals with the bounds. You've got to show some work. It's not just a number. Okay, I mean, somebody who just copied my answer could have done that. The only way I know you did the problem is if you have an integral with bounds, or 2 integrals with bounds, yeah? What about this one? 95.3007, so 301 or 300. Okay, again, show the integrals. This was also a question on the homework that was starting to make me a little frustrated here. 2 sine of x has a period of 2 pi, so in 4 pi it goes through 2 periods. So, true or false, the area is 0. False, okay? These two things are not the same. Integrate 0 to 4 pi and find the area between the axis and sine 2 sine of x on 0 to 4 pi. I know they almost read the same. They are not. This can be 0. It can be negative. It's all good. This must be positive. Period. Okay? It's not net area. It is area. No negatives. No 0. Okay? Unless for some reason the region was 0 wide or the function was 0 high. It should not be 0. So it's not 0. Okay? Do use symmetry, however. Wouldn't you say that this is 1, 2, 3, 4 regions that are exactly the same?
Yes.
So let's use that. 4 times a single region from 0 to pi. Cool? That's 8 times, what is the antiderivative of sine? Negative cosine from 0 to pi. That's 8 times, what's negative cosine of pi? 1. What's minus a negative cosine of 0? Minus a negative cosine of 0 is plus cosine of 0, so 1. And therefore it is 16. Not 0. Gonna kill me with the zeros. All right. How about this one? Did you get 2? How about this guy? Did you get 36? We don't hear a lot of yeahs there. Okay. And did you get 3 log of 2? Natural log of 2. Cool.
Would you go back to the GCD?
Negative 3?
Most definitely not negative. You are fine in there.
No,
What? Which one? D. Negative 3 natural log of 2 is a big, not what I got. I got 3 log of 2.
Yeah.
You got negative 3 log of 2? Yeah, I'm definitely right, because negative 3 log of 2 is definitely negative. So that's no. Shall we talk about this one? Okay, here we go. Where's the vertical asymptote here? 2, okay. When I put in negative 1, just to see whether the graph is above or below the axis. So if I put in negative 1, I get a positive, yeah? So the graph is positive up here. And if I put in 3, I get a negative. The graph is negative down here, okay? From 3 to 4 is this region. So if I want to make this positive, I have to say, all right, I'm going to do the integral, but I have to take the opposite because the heights are negative. Are you down? From 3 to 4. Now, it's up to you how you work with this. If you keep it this way, then you better doggone well use a U sub on this because you've definitely got a negative du issue going on. That, if you do it that way, you've got to be careful. But here's an easier way. Can you just distribute the negative? Now, when you distribute the negative, do I put it to the top, the bottom, doesn't matter, or both? So here, negative 1/2. Is this the same?
Yes.
Is this the same?
Yes.
Is this the same? Okay, so I ask you again, bottom, top, or both? It would help you a heck of a lot if you put it on the bottom, because then the x turns positive. Then your du wouldn't be negative. It's a heck of a lot easier. If u is x minus 2, then du is just straight up dx. And when x is 3, u is 1. And when x is 4, u is 2, so it becomes from 1 to 2 of 3 over u du, which is 3 log of absolute value of u from 1 to 2. That's 3 log of 2 minus 3 log of 1, but 3 log of 1 is 0, so your answer is 3 log 2. Other questions on this bad boy you'd like to go over in more detail besides seeing the answers? Any of these pages, let me know. Yes? What? Be on the back side? Yep, you bet. Okay. All right. Now, if you thought, I don't know, I don't even barely remember secant. I definitely don't remember secant squared. Boy, I hear you. I'm with you. But wouldn't you agree that on negative pi over 4 to pi over 4, the adjacent side is positive, so cosine is positive, so sine or secant is definitely positive. So I don't care. Let's just say the graph looks like that, which kind of it does. I just know it's positive, and that's really all you have to know. Is it above or below the axis? So do you know to negate or not negate the height? So secant as possible asymptotes and all craziness, but for this interval, it's good to go, it's positive, we're good. So the area setup, I don't need to negate it because the region is above the axis, and I just straight up integrate secant squared. You with me? Okay, now that, you want to just recognize, that is a known derivative. What is it the derivative of? Tangent. This is tangent. And then it's just busting out the trig skills. Tangent of pi over 4 minus tangent of negative pi over 4. Tangent of pi over 4, opposite and adjacent of 1. Tangent of negative pi over 4, opposite and adjacent of the same number but opposite signs. So that's negative 1. So our answer is 2. That's what it is. Does that make sense? Yes. Other questions on this fun sheet with staple? Alrighty. Okay, cool. Can I get this today? Alright, you can keep 62 until tomorrow. We'll finish going over the notes, do a little AP practice. And you took a test last Friday. I still haven't given it back yet. We still haven't told it yet.
It's fine.
What are you gonna do? It's just not enough time to pay you. If you really wanted to see your test, I applaud that. Come in 7th grade, and I'll try and figure out a time. Or at the very least, we'll go over the common mistakes. Have a good day. Yep.
Trying to print off set 62